All right, so now that we know how to use our calculator to help us find things like type in tangent of 17, which is just basically buttons, we're going to learn how to use it in a triangle and find sides. So first thing we're going to remind you is that the Pythagorean theorem, a squared plus b squared equals c squared, you can always use that in what kind of a triangle? A right triangle, and A, B, and C are side lengths. They are not angles. A, B, and C are the lengths of sides in a right triangle. Are you with me? I can show you one example. Pick, do you want me to do A or B? Quickly.
A.
A. All right. So the only side that really matters in your A squared plus B squared equals C squared is what side, Bailey? In A squared plus B squared equals C squared, it's only one side that really matters when you label it. Which one is it? The C has to be the hypotenuse, right? So I'm going to call that a little c, and I'm going to say, write down my formula. You know what? Let's do letter B because it's a little bit harder. This one's pretty straightforward. You can throw your sides in there, square and square root. But what about this one? If this is a C, then this is my unknown. And you would have 120 squared plus x squared equals 122 squared. Are you following me on this one? You have to have the two sides, the legs we call them, equaling to the longest side, the hypotenuse, and you have to square it. Okay, so this question, a squared plus b squared equals c squared. Do you see how we're going to set it up? Everybody all right with that? The two shorter sides squared added together equal the hypotenuse squared. So now 120 squared, 12, 100, oh, this is a huge number. I have no idea. I don't know. What's 120 squared?
Yeah, that's right.
That's right? Okay, what's 122 squared? Say it louder, Adrian.
14,880.
14,880?
4.
4. 14884. Okay. See it? Okay, so to finish, you'd have to subtract 14400. You would end up with x squared is equal to 484. And your last step to finish, Ashlyn? Square root, and that's going to be, I'm going to guess 22.
Yep.
Wasn't a guess. I knew that one. Okay. So the side length of x is 22. It should make sense. The lengths of your two legs that make 90s should never be more than the hypotenuse. The hypotenuse is always longest, right? So if you get an answer for some reason that's bigger than your hypotenuse, you know you did something wrong. Okay? Good check. Do you remember that? Okay. That's just a quick review on how to use the Pythagorean theorem. You do it every time you have a right triangle. Go to class example number 2. We're going to use our trig and our Pythagorean theorem to help us solve real life problems. This is very real life. This happens all the time. This is when my brother-in-law called me. He's welding. He's on site. He's on an oil site. He's like, I have this pipe. I got to make this fit. What angle should I put it at? I said, get your calculator. He's like, I don't have one. I'm like, well, on your phone, you have a calculator. Turn it sideways. You'll find the sign button. And I helped him walk through how to find, because he had this pipe. You can't mess up, right? It's got to fit. So this is very, very useful. It says a ladder 4.5 meters long just reaches the top of a wall. You must draw a picture. So here's my house. Doesn't have to be elegant. It could be a tall silo. I don't care what it is. It's a house. I have a ladder. It's 4.5 meters long. It reaches the top of a wall. So this is going to be my wall. This is 4.5 meters. Now, don't mess up which side is which. Noah. Is that going to come to my house? Okay. The angle between the ladder and the ground. Now, some people forget where the ground is. Like, the ground is not difficult. We know where the ground is. There it is. Between the ladder and the ground is 65 degrees. Make a rough sketch. Did it? Determine the distance between the bottom of the ladder and the bottom of the wall. The bottom of the ladder to the bottom of the wall would be here. Call it X. Find out how far that is. There's 1/10 of a meter. All right. Can you use a Pythagorean theorem? Yes or no? I have some hesitance. Well, you have to have the lengths of two sides to use a Pythagorean theorem. A, B, C. You have to know two of them. Do you know two sides? No. Throw out Pythagorean theorem, can't use it. So now you're left with trig. SOHCAHTOA. Sine, cosine, or tangent. And you're like, well, would that work? Well, here's the deal. You have to figure out which side do you have and what are you looking for. And then decide. So I have the hypotenuse. What side are you looking for? Where's the x? Huh? The x is the ground. So is this the adjacent or is it the opposite side? Of this angle, it's the adjacent. Agreed? I have this angle, I have the hypotenuse, so I'm looking for the adjacent side. Adjacent and hypotenuse. What should I use? Have I ever heard of that before? What cosine? So you put down cosine. So I decided to use cosine because I have the hypotenuse and I'm looking for the adjacent. And adjacent and hypotenuse are the two sides involved in the cosine ratio. What do I put after I put down cosine? The angle. Always the angle. Always the angle. There's always an angle following the trig function. And I say cosine of 65 is equal to the adjacent, namely x, over the hypotenuse. Boom. This is a cross-multiply situation. Put this over 1. I have two fractions equal to each other. That means I can cross-multiply. X times 1 is x. Now all I have to do is type in my calculator the cosine of 65 and multiply it by 4.5. Go ahead. I want to know how far it is between the bottom of the ladder and the bottom of the wall.
1.9.
1.9 is a possible answer. Maybe, I don't know. Anybody else have a different answer? You all think it's 1.9? My picture wasn't very good then, was it? That's okay. Anybody else is going to be size 1.9? Okay. I don't think you're beyond. Probably somebody did. If you type in cosine of 65, it gives you an open bracket. Don't go like this. That will be the wrong answer. Okay, depending on your calculator, some calculators do not, that will be wrong. Type in cosine of 65, get your answer by hitting the equals button, and then times it by 4.5. Okay, be very, very careful. If you want to put it all in one line, Isaiah, make sure you put a bracket there. Okay, cosine is only cosine of 65. Yeah? Y'all in favor? Okay, good. Next question. Determine the height of the wall. Oh, same thing, same picture. Find the height of the wall. Well, now I know that this is 1.9. Now, can you use the Pythagorean theorem? Yes. Should you? Well, they want you to. Okay. So let's go 1.9, do it over here, squared plus b squared equals 4.5 squared. Agreed? The two legs of the triangle squared and added together is equal to the hypotenuse squared. Call it b. I don't care what you call it. We'll call it b. Tell me what you get, quick. Final answer.
4.08.
Anybody else have a different answer? So we're squaring our 1.9, 19 squared, 361. .5 squared, I don't know what to do. It's huge. It's like 16, 17, 18, something. What is it? 20.25. Is that right? Mackenzie, is that right? 20.25? And then subtract 3.61. and you get something funky that has to be square rooted, right? I don't know. 17 point something. I don't know. Anyway, no, 16 point something. Square root 4.08. Are we good? 4.08? All in favor, say aye. Okay, so then we're good. What about, could we use trig ratios instead? Because what's the problem with that? This 1.9, I bet you rounded it. Did you round it? If you rounded 1.9, I mean, I'd be surprised if it gave you straight up 1.9. If you round it and stick it in here, you have room for errors. Well, let's check. So what if we did trig here? If I was going to do trig instead, I would not use my 1.9 because I rounded to get it. I would use this side here and this side here. That's opposite and hypotenuse. I would try it using sine. Sine of 65 is equal to the opposite over the hypotenuse. Now, which would you rather do? Which one is going to take less calculations? The trig. But I don't care what you do. Throw that in your calculator. Sine of 65 times 4.5, and when you end up with, is it close?
4.07.
4.07, rounded properly?
Well, no, you said an 8, so.
So 7, 8. So it is the same. Okay. Right? We can get to the same thing. So whether you use trig or whether you use Pythagorean theorem, they'll be fine. I would suggest you give yourself a few more decimals if you're going to use Pythagorean theorem. Okay? All in favor? All right. Go to class example number 4. I'm almost done. Here we go. Determine to one decimal place length of a hypotenuse of a triangle PQR. Okay, draw a triangle PQR. Make it a right triangle, because that's all we are talking about right now. In which angle PQR is 90. Uh-oh. What label does this 90 have? Do you know what it is? It's always the middle letter. Do you know that? So it's Q. Let's put P up here and R down here. Those two don't matter, but the 90 degrees does. Angle from, so here's how I do this, from P to R to Q is 28. So I go from P to R to Q. So this angle here is 28. Okay, so get it straight. You can make a lot of mistakes just having that wrong. PRQ is 28, and P to Q is 15.6. So first of all, get a good picture and label it properly. All right, it says determine to one decimal place the length of the hypotenuse. So let's call this little letter Q, because it is across from the big Q angle, right? The sides are the same letters, but in lowercase. All right, you're looking for little q. So here's what you look at. What do I have? What do I want? You have an angle. You have its what side? How does this side compare to that angle? Opposite. What do you want? Hypotenuse. Which trig ratio should you use? Sine. So begin. Sine of 28. Always put the angle after the trig ratio. Always. Sine of 28 is equal to the opposite over the hypotenuse. Shucks, this one is not a quick calculator question. You'll have to do one extra step. We're going to cross multiply because we have two fractions being equal to each other, so I can cross multiply. You will have 15.6 on one side, and on the other you will have q times sine of 28. So this requires one extra step. You see it? You're not going to go sine 28 times 15.6. No, you're not. You're going to go 15.6, and we're going to divide by sine of 28. So show me your steps, get it right, don't make a mistake because you didn't cross multiply properly. Now take your calculator, 15.6 divided by sine of 28, and give me the answer to one decimal place. 33.2. Does that make sense in the context of my question? Should that be 33.2? Well, it certainly has to be more than 15.6, right? So I'll go with it. So now 320 something, it makes kind of logical sense, right? Make sure it works. Yeah? So draw yourself a picture. Put your angles in where they go, put all the numbers in as best you can, and then say to yourself, what do I have? And what do I want? And that will help you determine which trig function to use. Does that make sense? Label your sides. Only label the sides that you care about. When people put adjacent in here, it's true, that's adjacent, but who cares? Like, don't use it. It just confuses you. Label the sides that you have and that you want. Okay, let's do one more example and I'm done. Use trig ratios to determine the lengths of A to B and A to C in the given triangle. Let's do AB first. What side will we call this? What will we label it? We're going to label it C. Is it the opposite, the adjacent, or the hypotenuse? Opposite. Okay, 147, what is that? Adjacent, label it. Okay, label the two sides you care about. And now ask yourself, I have an angle, which trig function should I use? Tangent, opposite and adjacent, tangent, Maya, you with me? Okay, let's go tangent. Tangent of what? What always follows the trig function? The Logan. Logan, what follows the trig? As soon as I write down tangent, what do I write down? The angle. Always. 71. Okay, so tangent of 71. As soon as I write down the trig function, Melissa, what do I write down next? When I write down tangent, what goes next?
The
Angle. The angle. If you write down sine, if something is using a sine, Owen, what do I have to put next? The angle. Okay, get it? Evan, what do I put down? As soon as I write down cosine, what do I put next? Angle. Okay, good. I think we got it. So I write down tangent, I put the angle next. Then I do the ratio of the sides. So tangent is equal to the opposite, I'm going to call it C, over the adjacent, which is 147. Is this a quick and easy calculator question? Yep, this cross multiplying is just C equals, type it in your calculator, be careful, use brackets or get your enter sign first. It's the easy kind. Tangent of 71 times 147. We're just doing this. What do you have, Mackenzie? To the nearest meter, whole meter.
427.
427 meters. Does someone confirm that number?
Yeah.
Okay. So if this is 427, how might you find A to C? How many people want to use Pythagorean theorem? How many people want to use trig? I don't care. Do it however you want. What should we do? To use trig, Pythagorean theorem you already know, so you can use that. Let's show trig just to show how that would work. Okay, so I still am using this angle, so now this is the hypotenuse, and I'm going to label it across from big B as little b. Okay, I will still use, the question would be, should I use the hypotenuse in the adjacent, or should I use the hypotenuse in the opposite? Well, since you probably rounded on the opposite side, did you round to do 427? I would not use that because trig is really finicky with the rounding. Use the one that was not rounded, okay? So don't use the one you found unless you have to. Use the one that they gave you. So I'm going to use 147 and the hypotenuse. So the adjacent and the hypotenuse, adjacent and hypotenuse, cosine, right? So cosine of what? What do I write down after I write down cosine? The angle, right, Hannah?
Yes.
71 equals the adjacent 147 over the hypotenuse, which is B. Is this a quick and easy one? No, this requires you to multiply or to divide, right? So cross multiply, you have 147 on one side equals B times the cosine of 71 on the other. So divide by cosine of 71. So I hope you're really good at then you'll have it. So 147 divided by the cosine of 71. Okay. Or cross. Melissa, are you okay with the cross multiply step? Kind of. When you have an equal sign, you can go like that, right? Just write it all down. Then you're looking for B. So you have to get rid of the cosine of 71. Okay. You have 20 minutes. The key here is label what you have and what you care about. What do you want? What do you need? Then decide what trig ratio to use.